Hi everyone, thanks so much for logging in for today's webinar, especially when the weather is nice and sunny outside, so we appreciate you taking the time to join us. I'm joined today by, well actually first of all, my name's Lindsay Teal and today's webinar should last around 40 minutes. And I'm joined today by Paul Young, who's from Mavitt and Associates. And Paul's one of their technical water specialists there, so he's going to share lots of really interesting insights into the industrial sector and all of the kind of top 5 water efficiency opportunities that we feel you could start to look at. If at any point you want to ask a question throughout today's session, you'll see on screen now that there's a panel which should be what you kind of see on your own screen. And just where the green box is, you should be able to see that there's a questions box. And in there, you can enter questions at any point throughout today's session, and they'll come to me. And what we will do is we'll stop at 2 points throughout, and I'll put as many questions to Paul as possible. And yeah, if there's any questions we can't get to, then he'll be able to follow up with you after today's session. You can also post your questions or perhaps some nice feedback using the Twitter hashtag ResWebinar, and you can tweet those to @ResourceScott. So if you are a Twitter user, then we would encourage you to do that. So why are we here today? Just before I hand over to Paul, the reality is that for large industrial water users, there's a huge opportunity to make significant savings with water. Not only do you pay for water via the unit cost as it enters your organisation, but you also pay to treat it and to heat it, and at that point you're increasing the value of that resource significantly. And then of course you face the final additional cost of discharging that water via in-house treatment works or tankers, or of course straight to drain. So like I mentioned, for organisations in the food and drink, manufacturing, engineering, chemical or other industrial sectors like yourselves who've dialed in today, you stand to gain the most by taking steps to become more efficient with water. So there's a host of actions and technologies and projects that you can undertake today, and the aim of today's session is really to get Paul's perspective on what some of those top 5 opportunities are. A lot of those top 5 are driven from a survey that we've recently done, talking to industry experts. And Paul's also going to share experience in these areas and how they might apply to your specific organisations using case studies and his experience. And he's also going to highlight some of the water management initiatives that hopefully as a result of today's session you can go away and put in place straight away. So before I hand over to Paul, I'm just going to launch a quick poll, and the question is whether or not really just how much of a priority water efficiency is for your organisation really within the next 12 months. And that should be on screen now, and the answers are high, medium or low. And what we're hoping to kind of gain from this is just an insight to understand where water sits. And we know that with energy and raw materials and waste, water can sometimes be slightly further down the priority list, and we're just interested to see where it sits with you. So those results are coming in now. We've got about 50% high, 36% medium, varying quite a lot. I think medium looks to be the winner mainly there. I'll close that now and share those results, and then I'll hand over to Paul, who will run the kind of bulk of today's webinar session. So as you can see, the final results are 31% high, 56% medium and 13% low. So quite a split there, but it's nice to see that over 80% of people believe it to be a high or medium priority within the next 12 months. So that's great. Thank you for taking the time to complete that. And I'll hand you over to Paul.
Okay, thanks Lindsay. Thanks everyone for attending today's webinar. Just further to the introduction provided there. What I'm here to do is just provide a sort of independent perspective on some of the top opportunities that Resource Efficient Scotland have identified from their recent survey and engagement exercise with not only industrial users but suppliers of technology and sort of water authorities. First priority sort of opportunity that came up was around staff education, and it's something that I wholeheartedly agree with based on my experience to date. As Lindsay said, I'm an environmental engineer working for Mavitt, and a lot of my work is in the water and effluent sector, particularly with industrial customers, and it's something that time and time again we feel is quite a key opportunity that sometimes goes neglected. So why is staff training important? It's because Time and time again, we find poor operational practices are most common cause of either a leak, water inefficiency, or a loss of effluent compliance. And it's these people-related problems that often outweigh sort of technological issues. The majority of sites I've been able to visit to date haven't really provided any significant focused water or effluent management training, and that can come down to a number of barriers. It can come down to lack of time, competing training priorities in relation to EMS training, actual on-the-job training, but many sites don't actually take any time to look at the cost impact of water and effluent and how your staff base in your business can actually influence that. And that leads to a scenario where you have staff that they may be partially aware, but they're not fully aware of the impact that poor decision making can have on overall costs. So how should we go about training our staff in terms of water and effluent management? The best approach I've always found is to make training collaborative and not prescriptive. So it should be quite an inclusive project that we're looking to launch here with our training. I find most of the time that workshop-based groups really work well. And I've used the word workshop because it shouldn't be sort of dictatorial staff training. It should get everybody involved across your staff base. And what we find works better in the training that I've provided to industrial clients is getting a mixture of staff in that base. So having the health and safety manager next to a production operator, having an environmental manager next to engineering staff, and getting everybody involved and encouraging an open discussion as part of the training as well to identify ways to improve. And as I've said, that it should include all staff, regardless of their role, who could potentially influence water and effluent consumption at a site. So what does a good training programme address? Two main things: financial implications and compliance implications. A common fault that I've seen with some existing businesses is that when they train their staff, they do focus quite a lot on the environmental aspects of their operations, and that's very valid. But in order to really sort of hit home with the importance of good water efficiency, your operational staff on a day-to-day basis should have an understanding of both the financial implications and the more serious compliance implications that could accompany a loss of compliance. So for that, it's good practice to go into a wee bit more detail and really explain to your staff in technical terms that they can understand the importance of effluent management and water efficiency. The first thing for that, I would say, is to make sure that your staff base understand the true costs of water, and it's something that Lindsay's hinted at in her introduction there. For example, when you're looking at your costs, do you consider the cost of hot water? It could be 3 to 5 times as much the cost of cold mains water, depending on the method of heating. Do you capture chemical costs for water treatment, cooling systems that you may incur on site? Do you look at loss of product in effluent? So you should be looking to try and do a bit of data analysis to quantify all these costs and then make sure that your staff are aware of the true costs of all the treated water that you use. Key more on the effluent side is also that your staff should have a thorough understanding of the key parameters that can impact compliance and costs. From sort of technical terminology that you would see in a trade effluent consent, this deals with things like the chemical oxygen demand, the concentration of the contamination, suspended solids loading, pH, things that can affect your trade effluent compliance. But it's important in a training programme not to focus too much on the technical terms, but to contextualise it in a way that the bulk of your staff base can understand. So it's about raising the awareness of the risk, but doing it in a way that the operators will, on a day-to-day basis, understand. An example of that would be a dairy with a COD consent limit. There's a chemical oxygen demand of 2,500 milligrams per litre, say on an example trade effluent consent. So what you want to do is get your staff into the sort of situation where they don't just see the materials that they're using, they see the actual risk in terms of water and effluent management. So they don't see, for example, chemical milk and whey, they see the danger, and they're aware of what the consent limit is, and they're also aware of how improper use of the materials that they use or generate within the process could actually significantly impact compliance. And put it in really simple terms, like we've done here, and looking at ways in which we can actually recover or we can better use these potential contaminants. A quick case study to finish off the section on suppose staff training is a recent project we worked on with a cheese manufacturer. And the background to this was they were struggling to meet their trade effluent consent limits because they were in an aggressive production phase, a lot of growth in the company, and they were struggling to meet their existing consent. But they knew that a lot of this was down to individual errors, so when we looked at their sort of water and effluent consumption data, we found that there was large spikes in their loading, and there was a lot of anomalies between their own results and the spot samples that were being taken by, in this case, Scottish Water, which was their authority, as well as significant variation in water use, which we couldn't really fully explain. The problem was the client had limited budget and physical space available for an end-of-pipe solution. So we were tasked with trying to improve the current situation without necessarily relying on a sort of capital investment in an effluent treatment plant. So no training had previously been provided, and that's something that we sort of quickly ascertained, and the client wasn't really sure how to go about sort of training their staff effectively. So what we did was we agreed to run a series of training workshops over a 2-day period, and as I touched on earlier, we made sure that this spanned all staff in mixed groups. And these workshops consisted of a 60-minute training session looking at financial, environmental and compliance aspects in detail, and then also, more importantly, a 60-minute group discussion where the group were free and there was no pressure applied to just generate ideas and to really have a brainstorm as to how to improve the process. Often you find it's the people that work in these production lines, if you are in a manufacturing environment, for example, that would actually know best on how to improve. So this was really successful. We got everybody engaged, everybody bought into the process, and by the end of the workshops we'd identified over 20 issues with the process and associated remedial actions, the majority of which were of quite low cost to the company. So there was a credible business case that came out of that project, and given the sort of scale of the sort of potential loss of compliance they were facing, the company invested in these improvements. And I'm pleased to say 6 months on, they were able to renegotiate their trade effluent consent, and that's led to annual operating charge savings of over £100,000 a year. So really significant savings, and really the crux of that was from a thorough staff training exercise, which was a nice outcome, and it shows that sometimes we don't always need to go for high cost solutions and overly relying technology before we address sort of operational issues. So it was a positive case study. The next opportunity I'd like to talk about, and something that came up quite prominently in the Resource Efficient Scotland survey, is looking at on-site effluent treatment. And I'm aware that there's quite a variety of sort of sector types and sites represented in our delegates today. So I've tried to make this general, but also hopefully there's a couple of things that you can take out specific to your own business. So effluent treatment, as we've seen, if it's well designed and operated, an end-of-pipe treatment solution is definitely an effective solution over the long term for making sure that you comply with the water and effluent regulations that apply. For industrial users, it's often necessary to comply with your trade effluent consent. That could be set by Scottish Water for a sewer discharge, or if it's to a water course, you'll be dealing with SEPA under perhaps the Controlled Activities regulations. And what we find is that compliance, first and foremost, is the major driver for investment. That's really the sort of the one guaranteed driver that would make you consider on-site treatment. But some of you may work in sites which already operate effluent treatment, and you may be looking to upgrade or perhaps completely overhaul your system. And what I would say is that as part of a long-term strategy, it can also make good financial sense. But from experience, the one lesson that we've all learned is that the project economics for these sort of larger scale projects, they must stack up. I've seen several examples of effluent treatment plant that's been poorly designed, or it's been designed and installed with perhaps insufficient basis of design, a lack of information at the design stage, and it's led to a situation where you have difficult in operations, plant not really doing what it's supposed to, and the investment's already been made. So the one thing I would take away from today is that make sure your project economics stack up and that you do your homework beforehand. What we find as well is that if you're in a site which manufactures a range of products and has a variety of effluent streams, it might be that you want to consider a balance of off-site disposal and on-site treatment to make sure that you have a viable option for the long term. And certainly some really strong chemicals might not even be suitable for treatment, so do consider off-site disposal when applicable. A key starting point when looking at an effluent treatment project is really understanding your process and the nature of the effluent that you produce and how this varies. So what we really recommend a lot of the time is a focused programme of sampling to make sure you gather that information. And why would we do this? Well, it's to look at all the sort of design parameters that you should really understand before embarking on the design, installation and investment in a new plant. So we want to look at the variations in the flow of effluent, the variations in your contaminant loading, the ability to understand the wider chemical characteristics of your trade effluent streams. You might understand effluent from a compliance perspective, where you're perhaps assessed on maybe 2 or 3 different parameters such as BOD, COD, suspended solids, pH. But when embarking on a potential treatment option, it's important that you do actually conduct a wider analysis of your effluent to pick up on any contaminants which might also require treatment but you're not necessarily assessed for. And often sort of continuous composite sampling is a really good exercise because it allows you to judge the impact of specific processes or time periods on effluent quality. And often this might not be picked up, for example, on a spot sampling regime that a site may have for its compliance. So we find that continuous sampling using perhaps composite sampling devices and laboratory analysis on a range of parameters really gives you a good thorough piece of information which you can then use to hopefully build your solution on. If you're on an existing plant, things to look at is the overall treatment efficiency and also things like the age of the plant and how does your existing plant compare to the original design intent. Time and time again I go to sites and they do have effluent treatment facilities installed, but as business and environment has changed, the site might have changed production style, it might have changed engineering setup, and this has contributed to perhaps a different type of effluent that's been produced. So it's important to look at how does the plant you have now compare to the effluent that you're generating now, and is it fit for purpose? And again, that's where sort of individual sampling exercises can really help by looking at maybe taking additional samples upstream and not just of your final effluent to look at how is each component of your effluent treatment plant performing. Is it the full system or is it individual elements that need addressed? And can you look for solutions specific to one element of the plant which might save you money in the long term? In terms of selecting appropriate treatment, if you do get to a stage where you're looking at a new plant, it will depend on your discharge consent requirements and other regulatory requirements, particularly if you are permitted under the PPC regulations on a Part A basis. It also depends on the space you have available and also the anticipated future operations of your site. And that's a key point, is to make sure if you are looking at an engineered solution for effluent treatment, make sure it will do the job in 15-20 years time if that's the planned future for the site. Don't just build it based on the sort of current effluent that you produce. Future proof it if you can. And often it will be a combination of treatment technologies that might be required to achieve the desired results. Something I'd like to mention as part of this webinar, because it came up actually quite specifically in the recent survey, was anaerobic digestion. It's an established technique and a key part of Scotland's low carbon economy in terms of the processing of food wastes, agricultural wastes, and there's a number of plants already up and running in Scotland. Essentially it's the breakdown of organic material in the absence of oxygen, and that produces energy-rich biogas which can either be used on site or sold for profit, and also a nutrient-rich digestate sludge which can often be another revenue stream. And what we're finding is that it's an emerging technique for effluent treatment, and smaller scale on-site systems are becoming more commercially available. Quick run through of the benefits and barriers if this is something that any of the delegates today would be considering. Benefits of anaerobic digestion are that it provides a significant BOD and COD reduction, just given the very nature of the process. So if you have high BOD, high COD effluent, it might be worth considering as an effluent treatment technique. The heat and power that you can potentially generate can be used to good effect on site. And when you combine these two factors, this often leads to a high cost saving potential. Now, obviously that's married with a significant upfront investment that's required. Another barrier is that it's not suitable for all effluent types. And while we're involved a lot of the time with looking at the feasibility of these projects, we find that it's not suitable again for all sectors. And if you were to go down the road of AD, there might be additional legislative and permitting considerations that you'd have to cover if you wanted to install such a facility on your site. So is your process suitable? If you were tentatively looking at it, the following checklist might apply. You'd probably be looking to generate over 5 tonnes of COD load per day. Anything less than that, and you might not get the required conditions. If you've got access to additional solid organic waste streams that you can mix in with your effluent, that might also improve the conditions for the AD to occur. That could be sort of additional waste from a neighbouring industrial site or from agricultural waste. In my experience, it's best suited to food, drink, dairy and biofuel sectors, and they're the sectors where we've seen it most commonly applied, where you've got high strength, organic nature effluent with high COD. And I would say, harking back to my previous slides, is that a detailed analysis of your effluent and an initial feasibility assessment is a good first step before committing to any such project. Finally, just a quick comment on sludge waste, which also come up as a potential opportunity in the survey. Obviously, it's an unavoidable residual product from effluent treatment operations, and depending on the product you make, the nature of your effluent and the contamination within, it's typically disposed of as hazardous or non-hazardous, and that will just depend on the nature of the sludge you generate at the end of your process. And it's often not an insignificant cost when considering currently, always increasing disposal and transportation costs, particularly if you've got a hazardous waste stream that you have to send off site. So some techniques to bear in mind that's good practice to use include uses of centrifuge, filtered belt prefiltration and thermal drying. And obviously these techniques represent a medium to high level of capital investment, but if you do generate a significant volume of sludge as part of your process, then they're certainly worth investigating in more detail. And I think at this point we're going to ask if there's any questions. Or?
Yeah, absolutely. We've probably just conscious of time. We'll just take one question tonight and then we'll scoot on with the rest that we need to cover. So one question that's come in is, what type of effluent treatment technologies might be suitable for different sector types? It's a good question. It's obviously there's a variety of sectors and subsectors under the sort of industrial and manufacturing umbrella. So there's a range of techniques out there, and I would say that for most industrial effluents you really are looking at certainly preliminary treatment and some primary treatment. And when I say preliminary treatment, I'm talking about sort of basic sort of treatment that would apply to most effluents that you'd be looking to do first and foremost to get you near to compliance. So that might include pH correction, it might include simple balancing of your flow before you put it through a treatment plant, and certainly initial screening to remove any really significant coarse solids that are easily removable. For some sectors you might want to take that a wee bit further and apply primary treatment, and that's really where we're looking at a bit more advanced solid and COD removal it could be through additional filtration, it could be a chemical process where you're adding some flocculant and coagulant to precipitate out some solid, and also ion exchange if we're looking to remove colour and some solid components that way. There's a variety of techniques available. More specialised techniques include likes of dissolved air flotation, which is quite common for removing fat oils and greases, particularly within the food and drink sector. And then if you have a particularly high strength effluent that's biological in nature, then you're looking at secondary treatment, so aerobic or anaerobic treatment, really to get it down to a level where you'll comply with your limits. Probably don't have time to discuss all the techniques, but as I say, there's a range of techniques available, and it'll be a combination of different techniques depending on your sector type. Great, excellent. Well, we'll stop again at the end, so if you do have any further questions, then just pop them in that box that you should be able to see on your screen, and we'll stop again and ask Paul. So brilliant, thanks Paul.
Okay, so moving on, the next opportunity we want to look at is just water monitoring in general and use of meters and data collection. Really we find it's a key part to any water efficiency programme or individual project. If we don't get this right, we're more likely to make incorrect decisions in terms of how we spend our budget. It's critically important for a number of reasons. Without good quality data, we don't have a sufficient understanding of the operation of our process. We don't really have an understanding of the water efficiency, so we might have an indication of how much water we use, but we don't necessarily dig into how efficient are we and can we improve. Without data, we can't really identify potential improvements in any detail. And when you combine these factors, it leads to a situation where you don't have a credible business case to present, for example, to management to invest in a water efficiency solution. And really key to this is, I think for most large water users in sort of industrial sector, is making sure that you more or less understand your conceptual water mass balance of the site, understand your key flows in and out, where water's been used, and also focus on different types of use, ingredient use if applicable, water for heating, cooling, either directly or indirectly, cleaning is another big one, and we'll come on to that later on. So make sure you account for all your significant usages. So what would be good practice? In my experience, it's sites that account for over 90% of their water consumption and have more or less an up-to-date water mass balance. That's really a sign that you're on top of your water consumption. With a view to making savings, you should look to apply strategic submetering downstream, perhaps of your mains water supply, or if you use borehole water or treated water. And I'll come on to that a wee bit later on in a future slide. You should be actually using your data, not just collecting it, but actually using it to establish key performance indicators and targets that are specific to your process. Now this could be in relation to domestic water consumption, it could be in relation to a specific process or equipment, and actually comparing it to a factor that actually governs how much water you should be using. By doing that, you tend to identify potential problems a lot quicker. And if you are doing that, making sure that progress to these targets is actually communicated across the business. So make sure your staff base know what your water efficiency targets are. If you don't have any, consider setting some and tracking progress. Data collection methods vary. There's a number of things we can do to get a better handle on our water use. Some examples I'll talk about today are sort of more automated systems, physical metering, and then there's also non-invasive ultrasonic flow metering. So I'll just quickly run through the benefits of each. AMR now, automatic meter read systems, is quite an established technology, widely used within the industrial sector and often available from either your water retailers or from private suppliers as well. It's a great technique because it provides continuous data for you, usually within a 15 to 30 minute reporting frequency, and it can be installed on any pulsed output meter. So this would apply not just to your main supply, but any submetering you might have downstream or specific to a process. You can fit your AMR, link it up to a telemetry system, and with a simple software solution you have it on your desktop every 15 minutes. So it's something we recommend for a lot of larger water users to really help them get a handle on how much they're using. It minimises time and effort involved in collecting the data, and that's often the biggest barrier to data collection. But more importantly, it facilitates detailed analysis, so it really allows you to really look at individual processes in more detail and look for base loads and potential leaks, so it's very useful. Physical submetering, again, you don't have to invest in expensive AMR systems to get the most out of your monitoring system. For maybe small to medium enterprises or medium-sized industries, installation of a couple of additional meters might be all you need to get the data that you need to optimise your costs. So just installing fixed meters, whether it's maybe like a turbine meter or perhaps an electromagnetic meter, often is a cheaper solution. And there's usually a variety of meter types that would fit your pipework and the type of space you have available. And if we do this in a strategic way, we can often identify hidden savings by monitoring, for example, and I'll come on to this a wee bit later on, maybe some feeds that don't necessarily result in an effluent. So you make sure you're accounting for them, and then you can use that as evidence to maybe adjust your bill with your water retailer. Disadvantage, I suppose, of submetering is it does require a wee bit more ownership compared to the automated systems, so you do have to get around and get these physically installed, have people responsible for reading them. There'll be maintenance and replacement issues from time to time, particularly if you're installing some cheaper meters which are just simple turbine. models. And it's harder to trend the process variations because you're having to do a lot of the data analysis yourself, probably, perhaps using an Excel spreadsheet, and there's a bit more time involved in analysing the data you get. But for smaller sites and you're looking to take weekly, monthly readings, it's a great solution. Finally, I'll just touch on ultrasonic flow measurement. Again, this is really good technique because there's no disruption to the process or the pipework. It allows you to quickly sort of benchmark flows across a site just by clamping on the meter for maybe a couple of hours if you know roughly how your process runs. And it's also usually got the ability to monitor other media as well. So we can, for example, at a dairy site, you could monitor water, milk, cream, glycol for a chiller plate using the same flow meter. So it allows you to build up quite a lot of useful information. If you were looking to install non-invasive meters permanently, I would note that they're quite expensive compared to the sort of fixed submeters. We find it's better as a precursor to a sort of an M&T system. And also when you're using these devices, it's important to remember that some external factors can influence the accuracy. So if you perhaps have quite a rough pipe surface, or you're not really sure what the temperature of water is through the pipe, or if there's insufficient space to really get a true reading, some of these things can influence the accuracy, but time and time again we find them very useful. Some quick examples of strategic metering. So as I was saying, in a monitoring programme you should always be looking to A, quantify water consumption in areas that you can improve, and B, ones that don't necessarily generate an effluent or a wastewater stream. So you quantify these in detail, and then you make sure that your water and effluent bills reflect the fact that you don't send this water to drain. So some examples of that would be in a food and drink site. If you look at the top photograph here, we've got a sort of tray of like biscuit mix. This was at a bakery. So if I was in charge of that system, I'd want to know exactly how much water I'm using as ingredient, because that's not going anywhere apart from the final product. And if we quantify that, we can make sure that our water retailer provides us with the right allowance, and we're not overpaying on effluent costs. Similar examples in the photographs below are evaporative cooling and steam boiler systems. So the vast majority of that water has been lost to evaporation. Again, it's not resulting in a wastewater charge, so it's important to know and quantify that so we can check our bills. Sometimes it's also good to look at the efficiency of processes. So some sites will actually treat water prior to supply to the process. So we've got here an example in the sort of corner photograph of an RO skid, and we would want to be looking at metering perhaps in and on the outlet to make sure we monitor the efficiency of the process over time, and we don't leave it too late to carry out maintenance and things like that. So from a process management point of view, metering is also a very good solution. Quick case study on this. Recent project we did with a ready meals manufacturer, and the graph here shows basically what we were coming into when we were called upon. Water use was out of control at the site. You see 6 metres cubed per tonne in February, and then in August it's nearly 10. So Clive were really struggling to get to grips with how to deal with this and streamline it. And the problem was that they didn't have any actual monitoring capability downstream of the main supply meter. So we came in and we used a suite of ultrasonic flow meters over a 2-month period to account for basically the bulk of the water consumption on site, with a view to understanding how efficient was the process running and also identify the most inefficient areas. So we uncovered leaks as a result of this from 2 major tanks, just with some simple monitoring. So within a day on site, we'd accounted for 29% of the excess consumption. And simple repair of control valves was all it took to deliver an instant saving. So positive was the company reinvested that saving to install a dedicated AMR and data viewing system because they didn't want to repeat the mistakes of the past. So now they've got 60% of their process water use subject to real-time monitoring, and the management team can go in and look at that on a 24/7 basis. And since they've taken the time to develop that mass balance and the automated system, they've reduced their water and effluent costs by, again, over £100,000 a year. So really having a good monitoring system in place, more often than not, it will deliver significant results. Quickly move on to the final opportunity that's come up in the survey, and that's just cleaning in general. So For industrial users, process cleaning is often the highest percentage of water use, particularly in the food and drink sectors and in the chemical sectors, where cleaning is of paramount importance. And it's the efficiency or the inefficiency of the cleaning that exerts a high influence on water consumption, and then the impact of that is your effluent contamination as well. And a lot of it is operator-led, so sometimes you've got cleaning activities that never completed the same way twice, and that can cause problems with spikes and loads in effluent. One way around this is to look at more sophisticated automated clean in place systems. So these are essentially automated cleaning systems for vessels, pipework. So they'll be installed in situ and they'll deliver water and chemical to these systems on a controlled basis, far more controlled than we could probably do with some manual operations. And again, they're most common in these sort of high priority sectors for it, so it's food, drinks, brewery, chemical, pharmaceutical and cosmetic sectors, where obviously there's a lot of sort of other legislation that requires stringent cleaning. If you're considering automating your cleaning, again, bear in mind that while it's a very positive solution, it may represent more of a medium longer term capex investment. So just like anything, it's important to understand the true business case of this, and we want to examine the water used in cleaning, account for the energy you're using, are you using hot water, and the chemicals that you may add as part of the cleaning process. So make sure you've got all these costs accounted for. But whether you use automated or manual cleaning systems, then the following checklist should apply to try and improve. Review chemicals regularly. Can you change the blend so it doesn't impact your effluent so much in terms of contaminant strength? Could you use a more environmentally friendly alternative cleaning agent? Could you reduce the concentration of chemical to get the same result? Could you review the duration of your cleaning? Is a 50-minute rinse good enough, or could you get down to a 45-minute rinse without impacting process quality? And examine the impact of changes in your process conditions to inform decision making. And what I mean by that is that if you have an automated system, just because it's been installed a certain way, it may be that you can optimise the settings to deliver a greater saving for you. Final point would be that you should be looking to recover spent product and reuse water if possible as part of cleaning. Got an example here again from a dairy site where you've got sort of milky water being released to drain. Could a turbidity probe or some form of conductivity control be applied to recover some of that water? So these are the kind of projects that you should be looking at to recover water. Quick case study to finish. Chemical manufacturer, they had an automated system in place to wash product tankers, but the system had run under the same settings since installation despite changes to the process. So we were asked to come in and look at how much it was using and whether it was efficient or not, and once we trialled some sort of sampling over the different runs, we found that the water supply was excessive, and the site has since been able to cut consumption by 8,000 metres cubed a year. So that's just a point that even if you do invest in an automated system, make sure it's optimised for your effluent. Final case study to finish is a project we carried out recently with a textile manufacturer. They didn't have the luxury of an automated system, so they operated a manual rinse process, some basic rinse tanks. And they were directing the final rinse to drain, but they were keen to look at a way of recycling. So we carried out some data analysis on the quality of water within each rinse tank. And we found that the final rinse water was sufficiently clean, so there was not a problem in recycling it. And having investigated that, they've now recirculated that, and they're getting another saving from that. So it's just about keeping your eyes open for these kind of opportunities and how can you clean more efficiently. And that takes me to the end of my slides, so I'll hand back over to Lindsay to finish.
Great. Well, we don't have any other questions that have come in, so we'll skip on past that. I've got a couple of things I'd like to mention before we wrap up. And one of them is that Paul's obviously highlighted lots of fantastic things that you can do as far as projects, and some of them, educating staff or, putting more stringent measuring techniques in. And we've got lots of resources on the website we've got spreadsheets that you can use, templates for recording meter readings. We've also got walk around checklists, water specific, that you might want to download. And we've also got a staff engagement toolkit with posters and lots of other kind of tips and techniques about how to actually engage staff. So it's worth going onto the website and having a look to see what you can use there, and of course everything's free to download. We've also got the Green Champions training course, which your staff, you might want to encourage staff to use to get them more engaged in the issues, or you might want to use that yourself just to kind of up your skills, not only in water, but also in energy and waste and raw materials as well. And for the last couple of weeks, we have been focusing quite heavily on water. We're now moving away from that to focus on staff engagement specifically. So it leads on, nicely from Paul's first main point, which was about educating staff. And so over the next coming few weeks, we're going to have some workshops and webinars which focus specifically on engaging staff. So we're going to have fantastic techniques and tools and templates and everything that you can use to do that. So we'd really encourage you to go onto the website, take a look at what's there and book onto those workshops and webinars if you think they would be helpful for you. And of course, we've talked about lots of things today, but we recognise that there's lots of people from lots of different sectors on the webinar today. So some of the issues you might be facing may be really site specific, and we've got a host of experts that we can draw on to help support you for free on site or over the telephone. So people like Paul and also other water specialists. So don't hesitate to give us a call or get in touch via the website if you've got something specific that you want to discuss or have some help with. And just quickly before I say goodbye and thank Paul, I'm just going to quickly launch a quick poll, which is just to ask whether or not you would like support with any water issues or effluent issues that you have at the moment, and that should be on screen now. And I don't need to share the results with you, but if you take the time to complete that, then we'll know after this webinar that you want some contact from us, and we can of course talk to you about what kind of support that you need. So I think most people have kind of completed that now. A few more coming in. I'll close that just now, and really that's it from us. We ran over a little bit, so I do apologise for that, but hopefully everyone's been able to stay on the line. I just want to thank Paul for his time, loads of really, really interesting advice, and hopefully everybody found it useful. This webinar has been recorded, so we will put that on our Vimeo channel and also on our website and share the recording link with you. So if there's anything you want to watch again, or we'd encourage you to share it with your colleagues, then you'll have that link to do so. So thanks again to Paul, and thank you for everybody for joining, and we hope to see you at our staff engagement workshops and webinars that are coming up over the next couple of weeks. Thanks everyone.